All right. But when we do that, we need to make some assumptions for this question. Still, there is some unknown factor there. So if we do not fix this unknown factor, we cannot answer that question. So assumption, what kind of assumption we need? Making reasonable assumptions. First assumption, we assume that these cases have the same probability. Equally possible. That's reasonable, right? Yeah. That's the first assumption. Second assumption regarding the no match case. How about no match case? We cannot assume they have the equal opportunity, right? That's not reasonable, right? Can you assume no match case also has the equal probability with other? That's not reasonable. So you cannot make that assumption. Okay? Yeah. So what assumption do we make on the no match case? Okay. Yeah. Here, let's do this. Another assumption for the no match case. Yeah. Probability. We need a probability number for it. We cannot assume, but we need to, have a number for it. You can use statistics to find that number. Okay? You can do some experiment to find that number. Okay? Yeah. The index case, we have two cases regarding the probability. Index case, that means your function returns an index. Yeah, that's this part. Index case. Okay? Valid index. Okay? Index case. -1 case. No match case. No match. Your function returns -1. Okay? These two cases. So let's assume the first case, index, the probability equals P. P is a positive number between 0 and 1. Okay. All right. And, because the -1 case, that's the complement case, right? Complement. Okay? 1 minus P. With this parameter, we treat this P as a parameter. It's a given parameter. It's not a variable. Given parameter. Okay? So we use this known parameter, then we can describe the average case efficiency. Okay. All right. So now we are ready to find the average case efficiency. When you do average case efficiency, you need to factor in, you need to do the average on all the cases. Do not miss anyone, but for each case, you need to assign it appropriate weight. Weight. Yeah. All right. So here, the average we want to find, actually, it's a weighted average. Okay? So let's calculate a weighted average. So the weight is important. Okay. Two-step calculation. For this example, we do two-step calculation. Okay. The first step, we calculate subcase averages and overall averages. That two-step. Okay? Substep averages, we have individual subcase averages. Then, at the end, overall average. Two steps. Okay? Yeah. Now, let's do those two steps here. The first step, we consider calculate the average of the first subcase. Yeah. This is the first subcase. What is the average number of comparisons for this subcase? Okay? Yeah. It's easy to find. Okay? Yeah. Because we look at the probability, right? They have the equal probability. Each one 1/n, the probability for each element. Okay? Yeah. Weighted average. What is the weighted average? This is the probability, is the weight. Weight, value, weight, value, weighted average. Okay? So you multiply the weight with the value, okay? You add them up. Okay? Yeah. So the formula is like this. So this is the average number for the first subcase. What is the average for the second subcase? Only one case. So average is the same as the number in this for this case. Only one. Okay? Now you have the answers for two subcases. So the last step, calculate the weighted average. All right, so yeah, the first subcase probability P, the second subcase the probability 1 minus P. How to calculate the weighted average? That's straightforward. Yeah, straightforward. Yeah, so next slide, we find it. Yeah. All right. How to calculate overall average in this example. Combine two subcase averages based on their probabilities. Their probabilities are used as the weights, and we do the weighted average. All right, so let's fill in this table before we do the calculation. Okay. Index case probability P, -1 case 1 minus P. And averages, these two averages. Okay? Yeah. Now, the last step. We write a formula for the overall average in this way. Okay? Yeah. So you can see individual average number multiplies its weight, probability, and also for the second subcase. That's the weighted average. Okay? Yeah. Yeah. So although you can simplify this expression, that's the answer. Okay? You can simplify the expression. Okay? Yeah. But here I want to mention one very important concept we use a lot in this class, dominant term. Because we have many terms here. But usually when we describe the efficiency, we like to use its dominant term to describe. We ignore the minor terms. Not very important. And we use the dominant term. So here, the minor term +1 can be ignored, right? Yeah, because this +1. You know, very small. Yeah. You multiply this P, P is a positive number between 0 and 1, also very small. So we ignore a very small number. Okay? So the dominant term, we combine 1/2 here, the coefficient of n, 1 minus P, we combine these two coefficients, put them together in a parenthesis and simplify it. This is the dominant term. Okay? Well, so if we want to represent its performance, most of the time we use the dominant term. Okay? Yeah. All right, so that is the whole discussion about this example. So any question? No. All right.